Hello, my name is Joe Palomera and I'm here to show you how to use this GUI. When you first unzip the folder, you're going to find two files. This project2.m and this project2.fig. The .m file is the code, the .fig file is the GUI. When we run the .m file, it'll pull up the GUI. Here's the GUI. It's a September beam analysis. This, as you can see over here, you can analyze two types of beams. You can analyze a simply supported beam or a cantilever beam. But before we do this, we have to fill out a couple of fields. First, we have to fill out some beam specifications. These values are pre-given and can be changed and edited. First of all is the length of the beam, whether the beam is in tension or compression. Here it says tension. If you enter a negative value, that will be considered as compression. The moment of inertia and the modulus of elasticity of the wood you want to analyze. So here we'll change the value of the length and store the parameters. Now for the loads of the beam, now we can choose to apply loads to the beam, either point loads or distributed loads. First we apply the point loads. We're going to apply a point load of 4 at location 4 and we store the point load. Let's say we do not want to add any distributed loads. We still have to fill the fields out with zeros and press store. As you can see over here back in the MATLAB program, these two new files showed up, this pload.dat and this wload.dat. That is where the data is stored for the point loads and for the distributed loads. So it is very important to click these loads and to fill them out even if you don't want any distributed loads. Once you have all this filled out, we're going to start off by analyzing a simply supported beam. We just click it. You can see the code running in the background. Once it is done running, it will recommend us a beam size according to our specifications. We can choose to plot the deflection and it'll present us with the maximum deflection. We can plot the shear force diagram and it'll also give us the maximum shear force, and we can also plot the maximum moment. We can also plot the moment diagram and it will present us with the maximum moment. Let's say we wanted to add another point load of 5 at location 2. So we save the data, and let's say we wanted to add a distributed load of 3 starting from 1 all the way to 7. We store the data, we run analysis again, and then we can choose to replot the graphs, and it'll give us new maximum deflection, new maximum shear, and the new maximum moment, and their respective shear moment body diagrams. Now if we wanted to analyze all these same numbers through a cantilever beam, we simply just press the cantilever beam button, and again we just press the values, the push buttons to plot the graphs. Unfortunately, we didn't have the expertise to get through the shear force diagram and the moment diagram, but we were able to get the deflection down, so we were pretty proud of that. I hope this helped, and I hope we can update this file in the future and get the full GUI running properly. Thanks for your time and have a great day.